Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on proportions. Note, this is designed to be viewed after confidence intervals and hypothesis testing on the mean, and I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. A couple of things. The original part 4 of this series was lost. So this is part 4. I no longer have as much access to the same software, and I lost the sound on part 4, and so was never able to upload it. And so I'm re-recording this. So if it sounds different, if my voice sounds different, it's because we're using different software. If there are a lot of mistakes in it, I apologize. I'm not as able to correct those mistakes, and it's been a long time since I've gone over this, and my narration notes aren't as good as they should have been. But this is part 4 of 5 of this video. And so I'm hoping that at least it covers this part. And we will just jump right in and try to get this taken care of. So next in this line, we're going to look at the sample size for a proportion. How do we find a sample size for proportions? And notice that the next topic here is how large a sample I should take. The problems that we will do next, instead of saying construct a confidence interval, will now say how many or how large I should take if I want to know the proportion within plus or minus something. And the within whatever is our error. And this error is called the margin of error, and how large a sample is our sample. This question should be asked before the data is collected. So how large a sample? Well, this is the formula for error. And we're not going to ask you to do this. It's just what happens is they manipulate this formula and we come up with the formula below. And that formula is N equals the Z alpha divided by 2 squared times P hat and Q hat all over E squared. So we know what these letters mean. We've used them in a previous formula, and now we're just ready to solve a problem or do an example. A couple of notes. To use this formula, we will need a reasonable estimate for P hat, which then gives us Q hat. So what should we do if we don't have an estimate of P hat? Well, consider the values of P hat times Q hat. If we have 10 for P hat, that gives us 90 for Q hat, gives us 0.09. 20 times 0.80 gives us 0.16. And so forth and down the table. You can pause and look at that, but as you read it, notice that the values vary from 0.09 to 0.25. And we could put other numbers in there, but what we discovered as a mathematician did that is about as large as it can get is 0.25, and it can get really small, but it can get really large. Or the largest it can get would be 0.25. If these represent our P hat and Q hat, what's the largest that it could be? Well, the largest it's going to be is 0.25. It will never get larger than that. Don't have an estimate of P hat, then to be as conservative as possible, we would want to use that largest value, which would be the 0.25. So what should we do if we don't have an estimate of P hat and Q hat? Then we should put in the largest conservative estimate, which would be 0.25. And that's the difference between the two formulas. If we have p hat and q hat, we use a good estimate for p hat and q hat. If we do not, we put in 0.25, because that will give us the largest estimate for n. So we have an example here. An education researcher wants to estimate the proportion of school children who read books in the summer. How many children must she randomly select if she wants to be 90% confident of knowing the proportion within 0.07? Assume that there is no estimate for the proportion of children who read in the summer. For the A part. For the B part, we want to use a previous study showed that 65% of the students read a book in the summer. Use this to estimate the proportion when determining the sample size. So we will do it in both ways. Here is our formula for the A part, where we do not know the proportion of children who read in the summer. Assume there is no estimate for the proportion of children who read in the summer. So this gives us n equals z alpha sub 2 squared times 0.25 divided by e squared. So we need to find all of the variables. So we need to know n. That's what we're looking for. Our z alpha sub 2, our z is 90%. That gives us 10%. That's two-tailed. And using our table, that gives us 1.645. Our p hat is unknown. Our q hat is unknown. That's what the A says. And our error is 0.07. Because our p hat and q hat are unknown, notice that is why the value, get my pen to show up right here, is 0.25. Okay, and our error is 0.07. And so now we're going to plug and chug. We're just going to plug in those values. Our z becomes 1.645. Our 0.25 comes down. Our error becomes 0.07. That is squared. The 0.07 is squared. Take this number squared times 0.25 divided by 0.07 squared. And when we hit enter, we should then get 138.0625. Remember that as we do sample size, that 138 surveyed would not be enough. We need a little bit more than that. So we should round that up to the next whole number of 139. So the answer here would be 139. Now let's look at the B part, which says a previous study showed that 65% of the students read a book in the summer. So we will list our N, our Z, our P, our Q, and our E. N is what we're looking for. Our Z, we're still at 90%, so that's still 1.645. Our p hat says that we're going to use this 65%. Our Q then is 1 minus 0.65, which is 0.35, and our E is still that within 0.07. Again, we will plug it into the formula, but this time we plug in our P and our Q, but we still type it in pretty much the same. And this time we get 125.6 or 126 when we round up. Notice the difference there. When we use a conservative estimate, we got a slightly higher number for the number of children we should survey or randomly select. Okay, here is your class activities. And again, she uses those to she uses those as quizzes, so I will not be providing the answers, but this is a great problem to try. You can check that on your calculator if you know how and your teacher's shown you, or you can email me and I'll be glad to send you the answers. I do appreciate you watching those. I hope they weren't too out of sync of the other problems. I really wish maybe I'll try something and be able to edit some things in there. But I do appreciate you watching these, and I hope these were helpful. Thank you again so much for watching.